So today, let's use the idea of uniform circular motion to derive equations of simple harmonic motion. So let's say you have a circular path which an object treads in a uniform speed. You know that the velocity is going to change because there is a change in direction. But if we have an object that is going through this circular path, or that is treading this path with constant speed, let's say 3 meter per second, let's say 3 meter per second, 3 meter per second at every point on the circle, then we say that that is a uniform circular motion. So let's say an object starts from here, moves with a constant speed, and then gets here. So we can name this point A, and that point also B. So we have point A, we have point B. So if we draw a line from the center of the circle to the point B, we are getting a radius because it is from the center to the circumference of the circle. And then if we trace this line downwards, we are getting the arc distance, of which we can name Y. Now from A to the center, from this point A to the center, can also be termed as the radius, because it is from the center of the circle to the circumference of the circle. So with this, let us bring this triangle out. We have it this way, but this is not the radius because we are taking this from the where the Y was projected up to. So if we have it like this, now we can have our angular displacement, that is the angle theta, because we know that in a circular path the angular displacement is the angle covered by the object moving in the circular path. So we have our angle theta, we have r here, we have y, and then we can name this one x. All right, so this becomes a right-angled triangle. So looking at this, we can have using the SOHCAHTOA, meaning that sine theta is equal to y over r. Are we getting it? That is the opposite over the hypotenuse. The opposite is this, and then the hypotenuse is the r. So having had it this way, now we can remember from uniform circular motion that theta is equal to omega t, or when we have omega is equal to theta over t, from this we can get omega t is equal to what? Theta. That is, the angular velocity is equal to the angular displacement over time. Okay, so when we have it like this, it means that omega t over here can replace theta over there. So we have sine omega t is equal to y over r. Sine omega t is equal to y over r. So we can make y the subject by sending the r here. So we have r sine omega t is equal to y. All right. So if you have it this way, we all know that if you differentiate velocity, if you have dv over dt, you are getting a. That is acceleration. In the same way, if we have ds over dt, that is displacement. If we differentiate displacement with respect to time, you are getting velocity. And then in this case, we have the y as the arc distance over here. So if we differentiate y, we are getting the velocity, that is dy dt is equal to velocity. So we are going to have v is equal to dy, that is dr sine omega theta all over dt. All right, so the r here becomes a constant because we are differentiating with respect to t. The r becomes a constant, so it comes out. So we have r d sine omega theta dt. All right, so we have r d dt of sine omega t. Sine omega t. Now, maybe you've not been introduced to differentiation, let me show you something small over here. If you have sine and you differentiate, you are going to get cos. So let's say you have sine x. If you differentiate, you're going to get cos x. Now, if you have cos x and you differentiate, you're going to get negative sine x. Negative sine x. So let's say you have cos 7x. If you differentiate this one also, you're going to get negative 7. That is the differential of the 7x. So the 7 will come out. Negative 7 and then sine 7x. Because if you differentiate cos, you are getting negative sine. Alright. So if you have if you have sine 6x, you're going to have 6 cos 6x. Yes, you're going to have 6 cos 6x. So we are going to use that same idea here. So if you have v is equal to r dt of sine omega t. Now differentiating with respect to x, v is going to be, this r is here already. Now we will differentiate this and then we have omega cos omega t. Yes, v is equal to r omega cos omega t, or v can be equal to omega r cos omega t. So this is the velocity of the simple harmonic motion, but that is not all. We are going to continue in the next video. So we are moving on. So you see that we now have the velocity to be omega r cos omega t. All right, let's break it again. Now from trig, that is from trigonometry, we know that sine squared theta plus cos squared theta is equal to 1, which follows that cos squared theta is equal to 1 minus sine squared theta. And then this again still follows that cos theta, because this is squared, is going to be the square root of 1 minus sine squared theta. Okay. So in the same way, if we have cos omega t, that is going to be equal to square root of 1 minus sine squared omega t. All right. And then we saw that sine, that is sine omega t is equal to y over r. That is from this side. Sine omega t over here is equal to y over r. So if we have sine squared omega t, so sine squared omega t will be equal to y over r all squared, which is going to give us y squared over r squared. All right. So meaning that the cos omega t that we have here can now be replaced by 1 minus this, 1 minus sine squared omega t. So we have, all right, so this now means that v is equal to omega r, and the cos omega t is equal to this. So omega r square root of 1 minus sine squared omega t. And then we've seen that the sine squared omega t is equal to y squared over r squared. So we have v is equal to omega r square root of 1 minus y squared over r squared. All right, so v is equal to omega r. Now a simple way to solve this fraction is by making the denominators the same. So we know that r squared over r squared is the same as 1 minus y squared over r squared. So we have v is equal to omega r and then square root of 1, because this is okay. So we subtract, because the denominators are the same, we subtract the numerators and take one of the denominators. So we have r squared minus y squared all over r squared. All right. So having had it like this, this can also be written as v is equal to omega r square root of 1 over r squared. That is, we are factorizing 1 over r out, and then we have r squared minus y squared. All right, so we have v is equal to omega r times, now square root of 1 is 1, and square root of r squared is r, so we have 1 over r, and then square root of r squared minus y squared, of which this will go with this. So we have v is equal to omega and then r squared minus y squared. Now because this is a square root, and then both the positive and negative sides will give you an answer here, so we can have v is equal to plus or minus square root of r squared minus y squared, because we know that if you have square root of 4, you can have the answer to be plus or minus 2, meaning that if you have negative 2 times negative 2 will give you 4, positive 2, that is 2 times 2, that one too will give you 4. So we have we have the velocity to be equal to plus or minus omega r squared minus y squared. Now the r over here is the amplitude, that is the maximum displacement from the starting point of the motion, the simple harmonic motion. So this r can be replaced by a. So in most cases, or in some cases, you are going to see plus or minus omega square root of a squared minus y squared. It's still the same. If you don't see a and you see r, it's the same thing. If you don't see r and you see a, it's still the same thing. So let's do